Engineering the flow of healthcare together with us, Group 1H. Assalamualaikum warahmatullahi wabarakatuh and a very good morning. Today, we'll be presenting to you our one and only product, which is the Smart Walking Stick. To begin with, let me introduce to you our team, the mastermind behind this Smart Walking Stick. We begin from the top left, we have Hasibul Hasan. Next to him is Syaifful Azam, Dalily, and me, Syakirah, and my friend Zarin Mesbah. Glad to meet you, and we hope you enjoy our presentation for today. So, we divide our today's presentation into 6 parts, and each of these contents will be presented by each of my team member. Now, let us begin our today's presentation with me, Syakirah, for the introduction. Here we have two most common tools in helping blind users in navigating their direction. First, walking stick, and second is the guide dogs. However, guide dogs can be very expensive and not suitable for certain culture. Therefore, in this proposal, we are proposing certain modifications to improve the standard walking stick. First, we integrate ultrasonic and water sensor to the Arduino. Here, we acknowledge the importance of safety for the blind user for any approaching object or the risk of falling due to the presence of water. Second, we alarm the user through the buzzer. And third, the most important part is this smart walking stick will be affordable to every user. Smart walking stick is very important for blind people in improving their daily life. According to World Health Organization (WHO), the population of blind people will keep on increasing until 2050. We can see increased pattern starting from 38 million in 1990 until it reached 75 million in 2020 and expected to reach 115 million in incoming 2050. We acknowledge the existing model of smart walking stick in current market. However, as we can see in these slides, the prices are very expensive. Therefore, we can say that not everyone has the privilege to own this expensive smart walking stick. It is one of the main reasons why we are producing this smart walking stick to help more blind people out there.
So now let's talk about our design statement. First of all, after interviewing all the patients, nurse, and the healthcare workers, we had an idea about some of the most common issues faced by the blind patients and their family members. So we created a profile of a patient named Mr. Ayman for our design statement. We also discussed the symptoms that he faced since he represents all the blind patients. We also listed down all his needs, which is very necessary to him, but he is not unfortunately getting all the assistance. So finally, constructing all these small information into a pile, we found our design statement, which is how can we help Mr. Ayman to improve his daily life by helping him to be able to walk and navigate directions safely with an affordable assistive technology. So this statement is not just stating the problems, but also is giving a solution that we are looking forward to for our project. That is, it is mentioning that the patient should be able to navigate the direction safely, and also it should be affordable at the same time. So this is giving the design statement for our project.
Let's move on to the result part. So this figure shows our circuit diagram by using Tinkercad, and this is all of the components that we use for our project. And the first component is ultrasonic sensor. The function of ultrasonic sensor in our project is to measure the distance of targeted object by emitting the ultrasonic sound wave, and the reflected sound itself will be converted to the electrical signal. The second component is photoresistor. We are using photoresistor in our project is because there is no water sensor in the Tinkercad, and we are using photoresistor to act as water sensor in our project, in our circuit diagram. And we are choosing this component because the function itself is quite similar with the water sensor function, which is photoresistor to detect the presence of light, while the water sensor to detect the presence of water. The third component is the buzzer. This buzzer is used to notify the user if there is something dangerous or something that will be harm to the user. If there is certain parameter, the value of certain parameter is out of the range that we already set up. The fourth component is LED, and the fifth component is Arduino Uno, our main components in this project. Next one. Okay, so this is the figure that shown the buzzer and the LED of the photoregister is turned on, and this buzzer and LED is turned on because we set up that this buzzer will be turned on if there is no presence of lighting. Since by using Tinkercad, we cannot actually test it with the real light, since we cannot do that in Tinkercad. And as I said before, we are using the photoresistor in our circuit diagram is because to act as water sensor um, for our smart walking stick. So the next one is, so this is the figure of simulation for the ultrasonic sensor in our circuit diagram. Um, So, as we can see from the first figure, the buzzer of the ultrasonic sensor is turned on because we put the object at 99.2 centimeter, which is less than 1 meter. So that's why the buzzer is turned on, because we set up the ultrasonic sensor to turn on if the object is 1 meter or less than 1 meter from the user. And the second figure shown that the buzzer is switched off since we put the object at 145.9 centimeter, which is more than 1 meter from the user. So that's why it is turned off. So next one. So this is the simulation video of our circuit diagram. So let's see the video. First, let's do a simple simulation for our circuit diagram. So as we can see that the buzzer and the LED of the photoresistor is turned on since we set it up that it will be turned on when there is no presence of light. And we set it up like that because we cannot test it by using Tinkercad with the presence of lighting. And next one, let's test the ultrasonic sensor. For the ultrasonic sensor, we set it up that the buzzer will be turned on when there is object that is less than 1 meter and 1 meter from the user. As we can see, when we put the object is less than 1 meter from the user, which is 86.9 centimeter, the buzzer will be turned on. And as we put the object more than 1 meter, which is 194.3 centimeter, the buzzer will be turned off. So that's all for the simulation video. So as we can see from the video just now, the sound of that those two buzzer is quite different, and it is obviously can be differentiated by the user, because for the photoresistor buzzer, we set up it to be a quite delay. The sound will be quite delay from the sound of buzzer for the ultrasonic sensor. So I believe that there is no problem for the user to differentiate the sound of buzzer for the ultrasonic sensor and the photoresistor itself. So generally for the photoresistor buzzer, it will be turned on due to the absence of light as we set it up like that. And for the ultrasonic sensor, it will be turned on when the object is 1 meter or less than 1 meter from the user. So
Good afternoon, and I'll discuss about our prototype. So due to the pandemic situation, our original pre-planned prototype, which was physical, was replaced with a simulation by Tinkercad. So let's say So naturally, some few component was also changed from our initial design. Let's talk about first like what didn't change. The ultrasound distance sensor didn't change in our Tinkercad simulation, so that feature still available in our smart walking stick. And there's still buzzer, but instead of one buzzer from our pre-planned prototype, there is two buzzer. That's because in Tinkercad we were unable to do uh, same like one sound for ultrasonic distance and sound twice for the water sensor uh, in Tinkercad because water sensor wasn't available in Tinkercad. And next is like photoresistor and LED. In our pre-planned design, there wasn't any photoresistor and LED, but in Tinkercad there is one. That's because our next component, water sensor, isn't available in Tinkercad. So water sensor was replaced with a photoresistor and LED. So photoresistor can detect light and signal the LED to turn on during the light, and it also buzzes when there's dark to notify the user there is dark. And if like there's both something a distance object is near from our walking stick and also dark, then both of the buzzer will uh, make sound in the same time. So in the end, the question arises, did we achieve our initial goal? The team's goal was to design a prototype that would help a blind person in their daily life. Although we couldn't design the prototype due to pandemic situation and it was replaced with the Tinkercad simulation. The simulation was functioning and we believe the smart walking stick can help a blind person in their daily life. And our thought about the final product is, although the second design is also good, but we should stick with our original design because it would be more helpful to a blind person in their daily life as it can detect the water, and because of one sensor the cost will be also lower. That's all.
Next, we go to the planning for the intellectual property and commercialization. Okay, as we can see, there is 5 important components that we need to fill up in the system so that we can have the planning for the intellectual property and commercialization. As you can see, the first one is the contributors, and all these contributors is our group member. Funding, we get the funding from the Universiti Teknologi Malaysia itself, and we do have external collaboration with 3 parties. And the first one is the visual impairment patient itself. The second one is the physiotherapist, and the third one is the nurses from the hospital Sungai Buloh. The reason why we do this collaboration is to get more information that can assist our process in designing and coming out with to produce product that will be able to help the blind patient. And for the benefits of the copyright is we aim to this product will be able to help the blind patient to walk and navigate safely. And the second one is we be able to help the blind patient to get an assistive device that is affordable. Okay, as for the target of the group, we aim for the blind patient and the age group that we target is adolescent above. The reason why is they have the capacity to handle this product. And for the height restriction, as like the other product, we do not have the height restriction because our product will be able to adjust the height, the length of the product according to the user's height. Okay, the last one is the copyright. As you can see, the copyright, this part, all the details of the procedure in designing, in coming up with the product will be have been explained in the procedure part. Thank you.
So now we have reached the conclusion for our project. So, to conclude, our team successfully managed to innovate the product, Smart Walking Stick, which was able to help the blind patients to walk and navigate safely. We did face a lot of problems throughout the project, but our team members had excellent team working abilities. So we managed to finish and came out with our final product in time, and the features being offered through our product would definitely make the lives easier for users with visual impairment. So finally, we can conclude that all the objectives for our projects were successfully achieved. Thank you so much for watching our video.